Hello friends, welcome to Actual Event Academy. In the last lecture, we have discussed about the necessary and sufficient conditions of equilibrium of a rigid body under the action of system of forces. Okay, so what are the conditions? So the conditions are the sum of resolved part of the forces along three mutually perpendicular axes. Okay, so we have x is equal to 0, y is equal to 0 and z is equal to 0, and sum of moments of the forces about these axes vanish separately. So we have L is equal to 0, M is equal to 0 and n is equal to 0. So we have the resultant as r is equal to x I cap plus y j cap plus z k cap, and g is equal to l I cap plus m j cap plus n k cap. Okay, so these are the resultant, and this is resultant, and this is couple of moment. Okay, so what we have studied that, let us consider a rigid body and let us take a random point AR. Okay, and this is our base point. Okay, so the position vector is r vector. Okay, and this is base point. Suppose we change the base point from O to O dash. This is O dash. Okay, we change the base point from O to O dash. So, with respect to point O, that is base point, we have the resultant as r and couple of moment as g. Okay, now on changing the base point from O to O dash, there is no change in the resultant, but there is change in couple of moment. Okay, so r and g gets changed to r and g dash. Okay, on changing the base point, okay, now let us move further. So let us discuss about a new topic, that is wrench. Okay, so wrench is a situation where the system of all 3D forces lead to a single resultant force, which is exactly parallel to the axis of moment. Okay, and the magnitude of resultant force is called strength of wrench. Okay, let us understand this with the help of an example. So we have a case of a nut bolt. This is nut and bolt. Okay, so this is our nut and this is bolt. Okay, so this nut rotates in this particular fashion. Let us say, okay, let us say this moves in a anti-clockwise direction. Okay, so we have a nut like this and we have a bolt. Okay, so rotation, let us consider the rotation in anti-clockwise direction. Okay, this nut rotates in this particular fashion. Okay, so this is the axis of moment, and now let us consider the resultant r as, this is the resultant r, and let us consider this resultant r is parallel to the axis of moment. Okay, so resultant r is parallel to the axis of moment. So if this situation arises, then that situation is known as a wrench. Okay, a wrench is a situation where the system of all 3D forces lead to a single resultant force. This is single resultant force which is exactly parallel to the axis of moment. This is axis of moment and this is the single resultant force. Okay, so this both that is resultant r and couple of moment are parallel. Okay, so under such some conditions where resultant r is parallel to couple of moment, that situation leads to a wrench. Okay, so now let us discuss invariants. Okay, so we have the invariants as, so the first one is the resultant magnitude of resultant is constant. This is invariant number 1. Okay, and we have Lx plus My plus Nz is equal to constant. This is invariant number 2. Okay, so what are invariants? A function which remains unchanged when a specified transformation is applied. In this topic of equilibrium in 3 dimensions, the invariants are those functions that are not going to change with selection of base point. Okay, so we have, let us consider a rigid body like this. Okay, and let us consider a random point as AR. Okay, and we have the base point as O. Now let us take the position vector as R vector. Okay, now we have changed the base point from O to O dash. This is O dash. Okay, O dash. Now let us take this vector as C vector. This C is a constant vector. Okay. On changing the base point from O to O dash, there is no change in the, we have studied that on changing the base point from O to O dash, there is no change in resultant, that is resultant remains unchanged. And secondly, we have there is change in couple of moments. Okay, so we have R remains same. So we have at point O, that is base point, we have resultant as R and couple of moment as G. Okay, so at point O dash, the resultant remains same. There is no change in this R, and there is change in G. So G changes to G dash. G dash. Okay, and we have studied that G dash is equal to G minus C cross resultant vector. C cross resultant vector. Okay. So we have two invariants as the magnitude of resultant is constant and Lx plus My plus Nz is constant. Okay. So now let us prove this. This Lx plus My plus Nz is equal to constant. How we can show this? Okay. So we have, let us calculate Lx plus My plus Nz. This we can write as Li cap plus Mj cap plus Nk cap. Let us take dot product with xi cap plus yj cap plus zk cap. Okay, and this is equal to G, couple of moment, and this is R. So this is equal to G dot R. Okay, now let us take on changing the base point from O to O dash. Sorry. So we have, let us take the rigid body and we have a random point as AR. Okay, and this is our base point. Let us take this as base point, and we have changed the base point from O to O dash. Okay, let us take O dash as constant vector. Okay, so at point O, that is original base point, we have the resultant as R, and let us take G as couple of moment. On changing the base point from O to O dash, there is no change in the resultant, so R remains same, and there is change in couple of moments, so this gets changed to G dash. Okay, so now we have, as studied earlier, we have G dash is equal to G minus C cross R. Now let us calculate G dash dot R. Okay, so this is equal to G minus C cross R dot R. Okay, let us take this as R dash. Okay, and let us now let us equate R is equal to R dash. Both are same. Okay. Okay, R is equal to R dash. Okay, there is no change in the resultant. Okay, only we have represented this R as R dash. Okay, for the sake of simplification. So we have G dash dot R dash is equal to G minus C cross R, that is value of G dash dot R dash. Okay, now let us calculate this. So G dash dot R dash is equal to G dot R dash minus C cross R dot R dash, and we have R dash is equal to R. Okay, so this is equal to G dot R minus C cross R dot R. Okay, this is scalar triple product. Scalar triple product. Okay, having two same vectors. Okay, so this is nothing but 0, and G dash dot R dash. Okay, so we have G dash dot R dash is equal to G dot R. Okay, and this is nothing but constant. Okay, let us move further. So we have next topic is calculation of pitch using invariant. So what is the pitch? Let us recall our discussion on wrench. Okay, so what we have studied, that wrench is a situation where the system of all 3D forces lead to a single resultant force which is exactly parallel to the axis of moment. Okay, so let us take this as axis of moment. This is axis of moment, and we have single resultant force as R. This is R and this is G. Okay, so P is the, what is pitch? So pitch is the distance between the line of action of the resultant and the axis of moment. Okay, so this is distance between line of action of the resultant and axis of moment. This is P. Okay, so this is pitch. Okay, so how we can represent the pitch? So we have G is equal to P times of R. So from here pitch is equal to G upon R. Okay, let us remember this relation. Okay, so now using invariants we have to find the pitch. Okay, let us calculate this. Okay, let us calculate a rigid body. Let us consider a rigid body and we have a random point as AR. Okay, this is our base point O. This got changed to O dash. Okay, so let us take this as this vector O dash as C vector. This is R vector. Let us take OAR as R vector and this vector is BR vector. Let us take this as. Okay, so now we have let us consider the resultant at point O, that is base point, original base point. Okay, this is changed base point. O dash is changed base point. So at base point we have, let us take the resultant as R and couple of moment as G. At point O dash we have, the resultant as R dash and couple of moment as G dash. Okay, and we have proved that there is no change in the resultant on changing the base point. So R is equal to R dash. Okay, but G is not equal to G dash. On changing the base point there is change in the couple of moment but resultant remains same. Okay, so we have, let us consider, so using the relation we have G dash is equal to P times of R dash. Okay, now let us calculate G dash dot R dash. So this is equal to G dash we can write as P dot R dash. So this is P R dash, P dot R dash dot R dash. Okay, so G dash dot R dash we can write as, okay, and we have studied using invariant. Using invariant we have G dot R is equal to G dash dot R dash is equal to constant. Okay, so G dot R we can write as Lx plus M, sorry, G we can write as Li cap plus Mj cap plus Nk cap, and R we can write as dot product with Xi cap plus Yj cap plus Zk cap. Okay, is equal to pitch times of, this is pitch times of, let us simplify, further simplify this. So this is equal to P times of R dash dot R dash. Okay, and R dash is equal to R. Okay, so this is equal to Lx plus My plus Nz is equal to P times of, this is R dash is equal to R, so this is R square. R dot R is equal to R dash dot R dash, this we can write as R dot R, this is R square, this is R dash whole square, this is equal to P dot R square, because R dash is equal to R. Okay, so from here pitch is equal to, let us further simplify this. This is pitch times of x square plus y square plus z square. So from here pitch is equal to Lx plus My plus Nz divided by x square plus y square plus z square. This is the value of pitch. Okay, so we have found the pitch of wrench using the help of invariants. Okay, so let us discuss the concept of central axis. Okay, so the locus of all the base points where the range happens is coming out to be a straight line. And that central line is known as Poinsot central axis. Okay, so let us plot a central axis. Okay, so let us discuss the concept of central axis. Okay, so the locus of all the base points where range happens is coming out to be a straight line, and that central line is known as Poinsot central axis. Okay, so let us draw a straight line. Okay, so on all these points, on all the points on this straight line, let us consider these points at 1, 2, 3, 4, 5 and 6. Okay, and let us consider this as n point. Okay, so at all these points the resultant is parallel to the couple of moment. Okay, so at point 1 r1 is parallel to g1, at point 2 r2 is parallel to g2, at point 3 r3 is parallel to g3. Okay, and at point n we have rn is parallel to gn. Okay, so at all these points we have the resultant is parallel to couple of moment, and that condition is known as range. Okay, so we have the locus of all the base points where the range happens is coming out to be a straight line, and that straight line is known as Poinsot central axis. This is the concept of central axis. Okay, so let us find the equation of this. So we have, let us consider the straight line, and we have the base point as O and the changed base point as O dash. Okay, and let us consider this, both are separated with a constant vector. Okay, so at point O we have the resultant as r and couple of moment as g, and at point O dash we have the resultant as r dash and couple of moment as g dash. Okay, so what we have studied that on changing the base point from O to O dash there is no change in the resultant, so r is equal to r dash, but there is change in the couple of moments, so g is not equal to g dash. Also we have the relation as g dash is equal to g minus c cross resultant vector. Okay, so now let us generalize this. So we have, for finding the equation of central axis, let us take c vector as r vector. So the position vector is r vector. Okay, so we have g dash is equal to g minus r cross resultant vector, position vector cross resultant vector. Okay, so what is the range? We have, let us recall that. So what we have seen that, let us take a nut bolt. Okay, nut bolt like this. This is nut and this is bolt. Okay, so this nut will rotate like this. Let us consider this rotation as anti-clockwise direction. Okay, so this is the axis of rotation. The axis of rotation is this one, which is the axis of rotation. Okay, that axis of rotation is same as axis of couple of moment. Okay, axis of couple of moment. Okay, and let us consider the resultant vector is also in this particular direction. So the resultant vector r is parallel to the couple of moment, that is g. Okay, and both are separated with a p, and that p is known as pitch. Okay, so g is equal to pitch times of resultant vector. So this we have already studied. Okay, now let us proceed further for the calculation of equation of central axis. Okay, so how we can solve this? How we can find the equation of central axis? So we have what we have studied that. So g, that is couple of moment, is equal to L I cap plus M j cap plus N k cap. Okay, and we have the resultant vector r as x I cap plus y j cap plus z k cap, and we have the position vector r as x I cap plus y j cap plus z k cap. Okay, and we have the equation of central axis as g dash is equal to g minus r cross capital R. So this is equal to L I cap plus M j cap plus N k cap minus r vector. This is position vector. So x I cap plus y j cap plus z k cap cross r is x I cap plus y j cap plus z k cap. Okay, let us find this one first. So we have x I cap plus y j cap plus z k cap cross, this is x I cap plus y j cap plus z k. This is equal to, this is I, this is j, and this is k. So we have this as x, y and z. This is capital X, capital Y, capital Z. So this is equal to I times of, let us take cross product. So this is y times of capital Z minus z times of capital Y. plus j times of, this is z times of capital X minus x times of capital Z, okay, plus k cap, this is x times of capital Y minus y times of capital X, okay. Let us replace this. Okay, so we have g dash is equal to L I cap plus M j cap plus N k cap minus this is I cap, this is y capital Z minus z capital Y plus j cap, this is z capital X minus x capital Z plus k cap, this is x capital Y minus y capital X, okay. Let us club this. So we have g dash is equal to L minus y capital Z plus z capital Y I cap, okay, plus j cap, this is m minus z capital X plus x capital Z plus k cap, this is n minus x capital Y plus y capital X, okay. So this is equal to, so we have g is equal to p times of r, so g dash is equal to pitch times of r dash, and we have r dash is equal to r, so g dash is equal to pitch times of this is capital R, okay. So this is nothing but p times of capital R, pitch times of capital R. Let us further simplify this. So we have this as L minus y capital Z plus z capital Y I cap plus j cap, this is m minus z capital X plus x capital Z plus k cap, this is n minus x capital Y plus y capital X is equal to pitch times of r, we can write as this one. So this is p times of capital X I cap plus p times of capital Y j cap plus p times of capital Z k cap, okay. So this we can further simplify as, let us equate this. So this we can write as, let us equate the coefficients of I, j and k. So we have this one is equal to p times of capital X. Let us further simplify this. Okay, so we have L minus y capital Z plus z capital Y is equal to p times of capital X. Okay, so from here L minus y z, sorry, L minus y capital Z, L minus y capital Z plus z capital Y is equal to upon capital X is equal to p, pitch, okay. Similarly the coefficient of j, this one is equal to p times of capital Y. So we have m minus z capital X plus x capital Z, okay, upon this capital Y is equal to p, okay. Similarly this one n minus x capital Y plus y capital X upon, this is equal to p times of capital Z, so upon Z is equal to p. So what will be the equation of central axis? So the equation of central axis is, let us equate the values of pitch. So we have this as, so we have L minus y capital Z plus z capital Y upon x is equal to m minus z capital X plus x capital Z upon capital Y is equal to n minus x capital Y plus y capital X upon Z. Okay, so this is the equation of This is nothing but the equation of central axis. Equation of central axis. Okay. So in the next lecture we will discuss about the problems on the central axis. Okay. Thank you.